few minutes early. Good morning. Thank you for coming. I know that, I shouldn't say this, but I know that there is a session right now on, this is the first basic public session of Exchange 2013, so I thank you for making the effort and coming and seeing me instead. I know it's pretty big competition, so thank you very much. My name's Stu Fox. You may remember me from TechEd from the last 5 years. I'm a technical specialist for Microsoft New Zealand. I cover the data center business, so basically Hyper-V, Windows Server, System Center as well. So today is an overview of Windows Server 2012 at Hyper-V, so the new stuff. So you probably will have seen, if any of you went to Nathan's session just before, he talked a little bit about some of the stuff, and I think there was an architecture session on just before this as well, talking about some of the Hyper-V stuff as well. So this is a quick overview. I honestly don't think I'm going to get through all the slides, so we might skip some of the stuff. Oops, I just did something bad then. There we go. So what we're going to talk about today, what's new, we're going to look at scale-up workloads, platform resiliency, storage, automation, networking, clustering, VM mobility, Linux as a guest. If we're running late, Linux as a guest might fall off. It's no offense to Linux as a guest. It's, but it's last. So I'm going to skip a couple of slides because I honestly don't really have time. So first thing, scale-up workloads. So what I've done in all these slides is I've given you a few references along the way to other sessions that are coming up. So if you want to learn about what we're doing, what we've done around Hyper-V performance and scale and what we've done in that space, Ben Armstrong's delivering a 400-level session in the next couple of days. I can't remember when, but he's delivering that session. So if you want to go and learn more about this stuff and how we achieved it, then that's the session to go to. So I guess, we've had Hyper-V out for, since Windows Server 2008, so 4 or 5 years now. And, one of the things that our customers have consistently told us is you need to scale up more. But when you scale, we don't want to just add more virtual processors. We actually want to scale properly, scale well. We don't want to just chuck more virtual processors at a workload and have it kind of scale next, up to 4 processors pretty well, then crap out after 8 or whatever. We want it to scale properly and scale well. But we also want you to, Microsoft, we don't want you to build features where you are blocked from deploying other things. So we don't want to deploy a feature where you have to stop using live migration, for instance. We don't like that in our other vendors. We don't want you guys to build that. So we've taken that on board. And so, and we've done a bunch of other work around, how we increase performance and how we scale to workloads that we've previously considered unvirtualizable. So I actually had to update this slide this morning. I don't know if you guys heard. You might have heard. We launched this thing called Windows Server 2012 today. You probably heard. Actually, and before I say anything else, I do have this to give away. Now, Nathan bottled it in the last session, and he actually couldn't give it away. So what I'm going to do is I'm going to give it away to the person who tweets the best tweet with the hashtag ver201, what the title of the session. So if you use hashtag ver201 and you tweet the best tweet based on my completely subjective analysis, I'll give you the notebook. Obviously, I won't give it you in the session. And just be aware, if you're a government employee, and that includes Datacom, I'm sorry, I can't give it to you. Just keep that in mind. It's nothing. It's not you. It's me. It's our antitrust, anti-corruption stuff. So I can't give it to you if it's government or Datacom or SOE. So but it rules out half the audience. So you've got a good chance if you don't work for those. So Hyper-V scale. You've probably had time while I've been ranting to have a look at some of that stuff. So I guess, we've taken the feedback on board. We scale massively. So 320 logical processors supported in the hardware, up to 4 terabytes in your physical hardware. Cluster scale, 64 nodes in a cluster, up to 8,000 VMs in a cluster. We just announced that this morning. I had to go and change my slide deck. It was 4,000 yesterday, but today, 8,000 VMs in a cluster. So obviously been doing some testing. Probably not going to hit that in New Zealand, to be honest. And for virtual processors, so for our virtual machines, up to 64 virtual processors in a VM, which is massive, and up to a terabyte of VM memory in a VM. So, massively scalable VMs. Live migration we allow, we used to we got a lot of feedback, hey, you can only do one live migration at a time between Hyper-V hosts, you guys suck, blah, blah, blah. We've basically removed the limit. So the limit is now, what can you achieve with your hardware? And we're not saying try and migrate, 100 VMs at a time. We're saying use what's sensible for your hardware. And that might be, hey, you're only migrating over a 1 gig network, so migrate 2. It might be you're migrating over a 10 gig network, you can do 4. What if you're migrating over RDMA or something and you're getting 40 gig or something, then maybe you can do a bit more. So we're not limiting you in software to the number of live migrations you can do. And likewise with live storage migration, which we heard loud and clear, hey, give us live storage migration, so we've given you that. Again, there's no software limits on that. Again, it's what can your hardware deal with. If you want to do 20 and your storage can cope with it, cool. But be aware, obviously, it creates storage churn. So just take that into consideration. Like I say, 64 node servers in a cluster. And the other limit we've removed is the limit of virtual processor to logical processor ratio. So we used to have this ratio of 8:1 for servers, 12:1 for client OSs. We've removed those limits. So basically, the processor overcommit ratio is now up to you. If you want to overcommit the hell out of your physical processors, go for it. We'll support you, but I guess be aware the advice might be, hey, you've overcommitted a bit much, scale back. So, but we're not putting a limit on that. And to be honest, we didn't find that limit helpful. And I don't think our customers did either. So, and if you want to, poke Ben on what he thinks about, the right ratio, poke him in that session. But we're not putting a hard limit on or a supported limit on that. So they won't give me hardware to run this stuff on. So if there's any vendors in the room who do want to give me 64 virtual processor or 64 logical processor machines, feel free. But they don't. So I've got to use some screenshots. 32 virtual processor Windows 2008 R2 screenshot there. There's a 32 virtual processor Linux system, I'd say, and there's a 64 virtual processor. Again, 64 processor. I think that's actually a beta version of Windows Server 2012, and I think you can see why we had to rewrite the task manager UI, because 64 virtual processors don't really fit on very well. And obviously a massive amount of memory as well. So so these things are real. You can deploy them as of today actually, and away you go. So that's scale. So we've done a lot of work on scale. There's some things I haven't been able to talk about just in the interest of time. Things like guest NUMA and those kinds of things. I think Ben will probably cover some of that stuff, but we have done a bunch of work around making sure that our workloads scale well by mapping physical NUMA topology into the guests as well. So when you're running those 64 virtual processor VMs, we still scale well. So moving on, storage. And again, VER302, Windows Server Hyper-V storage is Ben Armstrong again, and I think you'll hear his name a few times in the next couple of days. He's doing about 4 sessions for me. So he's going to go deep into Hyper-V storage. We'll have a quick look at some of the stuff here, though. So again, what did you tell us? You said, hey, we've got these fancy SANs that have got all this smart stuff built into them. Leverage that. Use it where you can. And so we've done a bunch of work in that, and I'll show you some of that as well. Just in a second, I've got a demo of offloading some of our storage operations to the SAN. Give us native access to SANs from the VMs. Don't make us use raw disk mappings or pass-through disks or VHDs. If we want to have native access to the SAN storage from a VM, give us that ability as well. So we've done that, and we'll talk about that. Help us reduce the cost of storage, and I don't know how many of you actually went to Nathan's session, but he talked about storage spaces and those kinds of things. That's one of the things we've worked on. Again, also working on things like really doing great support for things like shared SAS and those kinds of things, so we can use cheaper hardware to build clusters and those kinds of things. And also, at the moment, we're limited to just under 2 terabytes of virtual hard disk file. We actually like the virtual hard disk file format. Let us grow beyond that. So we've done that as well. So a few things we've done. Live storage migration. Yay. This was probably, I would estimate that from the customers that I talked to, this was probably one of the number one asks, was give us live storage migration, because operationally it just gives us a whole lot more flexibility. So live storage migration is built into the box. And Ben is going to talk a bit more about live storage migration in his session. but need to say it's built into the platform, easy to use, and we'll have a look at some of the offload stuff where it can do that as well. And like I said before, no limits, no software limits on it. Basically limited on the performance of your SAN. Virtual fiber channel. So, we want native access to our SANs from our VMs. Well, virtual fiber channel allows us to create virtual fiber channel adapters in our VMs and give them direct access to their own bit of SAN storage, their own unique zone. So the host never sees the storage at all. It's zoned specifically for that VM. And we work with live migration for virtual fiber channel. We don't have to, turn off things or anything. Virtual fiber channel works. We can live migrate it around your cluster, shared nothing live migration. We can do all that stuff, and it just works. This uses NPIV in the back end. One of the other things was, hey, give us different options around storage. We don't necessarily want to use fiber channel. And so we've also added support for running Hyper-V VMs on Windows Server file shares. So we've done a lot of work on both the file server itself and also on the protocol, SMB3, and we've made sure that we can run Hyper-V workloads on Windows Server file shares in a highly available way. So you can cluster, you can build a Hyper-V cluster using Windows Server file server clusters as the storage. Make those highly available, redundant, and with the work we've done in the SMB3 protocol, also make the protocol resilient to failure and temporary interruptions as well. So you can basically, run these things, run on a Windows Server file share, or an SMB3 file share. So it could be a NAS or whatever. And we've also introduced this new hard disk format called VHDX. So VHDX. Is a new format optimized for a few things. First thing is for size. So it's optimized. We can run up to 64 terabytes. This VHDX format can run up to 64 terabytes in size. So we can actually scale massively on a virtual hard disk file. And this basically means we don't have to step out to doing pass-through disks or raw disk mappings for a long time. 64 terabytes. And bear in mind that 64 terabytes is a limit of one virtual hard disk file. Windows Server, Hyper-V allows you to attach up to about 255 virtual hard disk files to a single VM. So potentially you could have 255 times 64 terabytes, whatever that is, petabytes or something, I suppose. So we can scale VMs massively. A few other things. Probably the other thing that customers have asked, have told us, and I heard a lot was, man, it sucks to have to shut down a VM to do a snapshot merge. That really sucks. And so yeah, we heard that, and we've fixed that. It's live VHD merge. So take a snapshot, delete your snapshot. The changes are merged immediately. We don't have to shut the machine down. They're merged live. And live new parent allows us, if you're using differencing disks, to move a VM and set the parent online rather than having to shut the machine down, that sort of stuff. So it's quite smart. We also add native 4K disk support, and that's actually an operating system feature, but we support that in Hyper-V. And we also support that in the VHDX format. We're well aligned in the VHDX format for 4K disks. So if you are running those on your SAN, you don't have to run an emulation mode or whatever, or on SAS storage or whatever. You don't have to run an emulation mode. We can run that stuff natively now, and that works well. And the last thing is offloaded data transfer. And what offload data transfer does is basically, it's a protocol we designed with Dell and NetApp, and what it allows us to do is offload storage operations to the storage. So instead of Windows, if you think about a traditional Windows file copy, say between servers that are attached, to the same storage, what happens with Windows Server is Windows Server reads the file off the disk, chucks it over the network to the other server, which then writes it down to disk, and so all this data that's sitting on the same storage has gone up the storage stack, across the network stack, back down the storage stack, back to the same storage pretty much. So what offload data transfer does allows us to in some in scenarios like this where the array supports ODX, is we can basically pick up that data. Windows Server says, Mr. SAN, move that or copy that data from there to there, and tell me when you're done. And what we do is, Windows Server chucks it off to the SAN returns a token, the token gets passed off to the other server that we're copying to, and the data actually gets transferred at the SAN level as opposed to being copied over the network. So instead of using disk I/O, instead of using all the network and CPU to do the file copy, it basically just happens at storage, and it happens extremely quickly. So that's what ODX does. Is that there's a few scenarios we can leverage it in for virtualization. A big one is creating fixed size virtual hard disk files. I don't know if any of you have played with Hyper-V and created a virtual hard disk file and gone, why does it take so long? And it's because it's zeroing every byte on the disk. We can offload that to storage, and I'll show you that in a second. Again, things like if we're doing a dynamic virtual hard disk or VHDX expansion, so when we're growing the disk, we can offload that as well. So basically, hey, grow the disk for me, and the storage will do that for us. Again, and things like VHDX merge. So when we're merging snapshots and when we're doing live storage migrations, we can offload that stuff to storage as well. The cool thing about ODX is that if your array supports it, then it's just on by default. You don't actually have to do anything. It just works, which is great. And there's your time to create a 10 gig fixed disk versus ODX versus non. And we'll actually have a look at that. So Dell have been kind enough to loan me one of their EqualLogic P5000, I think, and which is running the early preview of the version 6 of their firmware, which actually supports ODX. And I'm also going to show you the some of the unmap stuff. So we actually support in Windows Server the SCSI unmap command, and SCSI unmap lets us reclaim unused blocks on disk, and I'll show you that as well. So in my millions of VMs here, so in fact, first up, what I'm going to do is flick to this guy. I'm going to go new virtual hard disk. So this is a Windows 2008 R2 box running on a server. I'm going to create a new virtual hard disk. I'm going to create a fixed one, and yeah, we'll call it TechEd demo. We'll do that. We won't create 127 gig. That'll take a while. Let's create 15 gig virtual hard disk, right? And we'll go and do that. Okay, so while we're waiting for that, we'll go over here to this guy. I'll just move this out of my way. New hard disk, VHDX, why not? We'll create a fixed size one. Yeah, we'll call it that. Oh, actually, we'll call it TechEd demo just in case. X. Let's call it, what did we say? Did I say 15? 15 gig hard disk, right. And, oh, it's done. Okay, we'll flick back over here. Okay, so there you go. There's the benefit of ODX right there. So the offload, that just went to the SAN, SAN did all the hard work like that. This guy, Windows, is going 0, 0, 0, 0, 0. So, there's just one of the quick benefits of ODX. Super fast, access to storage, and the storage does all the hard work. Because in this case, the operating system's actually, firing a whole bunch of zeros at the disk, right there and there and there and there. The ODX case just says, create me this and do that to it and tell me when you're done. So I'll quickly show you the unmap thing as well, because the unmap stuff's quite cool. So what I've got here is I've got two VMs. One's running, they're both running Windows Server 2012, so they support unmap inside the guest. And so I've got on the SCSI controller, and we only support unmap in VHDX. We don't support it in VHD, and we'll show you that in this demo. So this one's attached to a VHD file, and this one is attached to a VHDX file. See that there. So what we're going to do is copy a file. So this file, 3 gig file or so, takes a few seconds. We're going to drop it out to copy it to the X drive, and we're going to do the same thing on the VHDX. And we will wait a bit while that happens. Any questions while we wait for that? The question is, if you have a simple server, single server environment without a SAN running on local disk effectively, is VHDX faster than VHD? I believe the answer to that is actually yes. and there's still with a bunch of optimizations in the storage format as well. But the other thing about VHDX is that it's actually a more resilient file format. It's slightly more resilient file format than VHD. So it's got a logging mechanism in the front of it. So should you lose power, for instance, it's much more resilient to corruption as well. So while it is more performant, it is more resilient. It is able to grow larger. So VHDX, and you will have noticed when I went through that wizard that VHDX was actually the default format for creating a virtual hard disk. That's because we think it's the right thing to do. You can convert a VHD to a VHDX. So if you're currently running Hyper-V and you've got VHDs, you can convert them. That's okay. You can convert them back as long as they're under 2 terabytes. As soon as they go over 2 terabytes, clearly that's kind of a problem. So but VHDX is definitely the recommended format. And also, we are one of the things, with the 4K disks support, dynamic VHD on 4K disks doesn't align when it grows. If you're running 4K disks for some reason, then VHDX also aligns better on those disk boundaries as well. So we're just about done here. So where am I? I'm on the VHD. And you can see there that our files are growing, so away they go. So what we're going to do is we're going to go and delete that file. Yep. And we're going to delete it off the other one as well. And delete. Yes. And then what we're going to do is we're going to actually run a command to re-optimize the volume. So Windows does this by default every 5 minutes, which is great, but it's not really good for demos, so you've got to force it. So we'll do a re-optimize, and we'll do the same thing over here. Screen resolution's not great, but here we go. Okay, so now we've re-optimized the volume. So you can see our file sizes up there. Our VHD is 3.64, our VHDX 4 gig. And so what we'll do, now that we've done that, is copy that file again, and we'll copy it to the Y drive, which is a volume on the same disk. And so we'll do it here on our, whatever one that is. That's probably our VHDX. And what you'll notice is I'm copying that file, but the volume's not growing. And we'll do that here. And you'll notice that the VHD should start to grow. There you go. So, that was lucky. So the VHD is growing. The VHDX isn't growing. So what we've done with the ODX, with the unmap support is inside the VHDX, we've passed down the commands to say we're not using these blocks anymore. Reclaim them for use. And so that's one really great thing that happens with VHDX is we're running on unmap supported volume. We'll just we'll reclaim that space. It's also exceptionally fast. The other thing we can do though is and I'll show you this, is we delete that thing off our unmapped volume. We re-optimize the Y drive as well. And I'll just redo the X as well. And then we'll just shut down that VM. This will be another one of those moments where I go, is it going to work? So we'll shut down that VM. And with any luck, what you should see is that VHDX size shrink right down again. So actually shut down anyway. The VHDX, the unmap support actually passes all the way down the storage stack from the guest VM. Oh, there you go. So it's shrunk down to 0.54 gig just by turning it off, right? So the unmap command has actually passed all the way down the virtual storage stack, all the way into the parent as well. So the unmap support allows us to reclaim a stack of disk space. So again, a great use of features that are in the array already. So we're just leveraging hardware there. Go away. So that's unmap and ODX. I'm not sure of the answer to that, to be honest. The question was, do you have to shut down the VM to reclaim the VHDX? And I actually can't remember the answer to that, whether it's whether you do or whether it will reclaim it periodically anyway. I'm pretty sure, yeah, I don't know the answer to that. But if you want to know the answer to that, go and ask Ben in his storage session. He might even be able to tell you. So there you go. There's the new enhancements. We've a summary, so we'll skip that. Oh, and so one of the other things we've done is, we've done a lot of work around the storage stack, and so one of the things we demoed at TechEd Europe and TechEd North America was this 1 million IOPS from a single VM. So we showed this back in, I think, June or so, that we could deliver 1 million IOPS from a single VM. So we can deliver massive throughput. And I guess, I don't really want to talk about the competition here, but one of the things that often gets thrown in our face by the competition is the parent partition architecture presents a bottleneck to Hyper-V, and it cannot scale well because of that parent partition architecture. At 1 million IOPS per second, 1 million IOPS, there is no bottleneck, really. You're able to virtualize anything with 1 million IOPS. So the parent partition architecture being a bottleneck, myth, total myth. And if you want to know more about this as well, go and see Ben's session. So let's move on. High availability. So again, what did you tell us? The fiber channel stuff again. Hey, we want access to the fiber channel SANs. We want to actually do some stuff around legacy apps that don't necessarily support clustering for some reason or another. We want to integrate better with our SAN. Again, we want to offload stuff, and we also want to do highly scalable virtual disks. We've talked about that a bit already. So some of the stuff we've done around availability, Windows NIC teaming. Daniel's doing a session later on this week on Windows Server NIC teaming. He'll talk about the improvements we've made there. Nathan, I think, touched briefly on it in his session as well. 32 NICs in a team, native in the stack, so you don't have to have some terrible bit of third-party software that doesn't scale or doesn't work properly. It's a native Microsoft stack, so you can use that. Continuous available file servers. I'm not sure if we've got any sessions on TechEd this year on continuous available file shares, but it's a new role inside the file services environment that allows you to have this thing called a continuously available file cluster, and allows you to have a multiple node cluster running Windows Server file services, sharing a single namespace and sharing a single set of disks on the back end. So you've got, whatever you just connect to server name / share name, and whatever, and you end up at one of those servers in that cluster talking to the same storage in the back end. And should one of those nodes die, we just fail that workload over to another node in that cluster, continuously available. And when I say continuously, I don't mean like there's like that 2-minute delay where Windows clustering goes, what just happened? And that same 2-minute delay where the client goes, what just happened? All that stuff's gone in SMB3 and the continuously available file share. It's amazing. CSV2, so we've done a bunch of enhancements in our cluster shared volumes, so we integrate really well with storage arrays. One of the things with CSV1 was that it was implemented as a storage filter driver, and it was a real pain in the neck for hardware vendors to do hardware replication, those kinds of things with. They had to write to the CSV stack to do it, and it was kind of a pain. It was also kind of a pain for antivirus and things like that. CSV2 basically gets rid of that as well. It becomes a lot easier, so storage arrays can just work natively doing replication of CSV volumes as well. We talked about virtual fiber channel previously, but now you can also build. Now you've got this fiber channel in your guests. You can actually also build a guest cluster on fiber channel storage. So you want to cluster 10 guests, 64 guests. You can build a 64 node cluster in Windows Server 2012. You can build a 64 node Windows Server cluster as well, Windows Server guest cluster as well. So the cluster can be virtual, can be physical, we don't care. And the virtual HBA enables that for us as well. You can still use iSCSI to do clustering as well inside VMs, but Fibre Channel gives you another option. We talked about concurrent live storage migration. It's there, and some failover cluster stuff. Oh, look, I didn't update this slide. Support for 64 nodes, 8,000 VMs in a cluster, we talked about it. Cluster-aware updating, so in the box in Windows Server 2012, we've got the ability to actually update a cluster. So, point at because obviously it's, when you're doing a 2-node cluster, updating it's not very hard. Failover, patch, fail back, patch. It's not very hard. We got 64 nodes. If you were going to do it that way, you'd be mad for a start. But just doing it manually would be just unsustainable. So. And even as you get up to 8, 10, 15 nodes, it's still not something you really want to do manually. So cluster-aware updating actually allows us to, as a role inside Windows, remediate that cluster for me. And so it'll go off, grab your updates from Windows Update, and take care of, here's this node, shuffle the workloads off, patch that node, reboot it, bring the workloads back, start on the next node. And that's what cluster-aware updating does. It deals with that orchestration process as well. And that's built into the box in Windows Server. So that's useful for Hyper-V, also useful for other cluster workloads as well. CSV2 we talked about. VM failover prioritization. One of the big things that customers said to us was, when we have a failover event, we've got no idea which VMs are going to start first, and it's basically a lottery, and it'll bring up some, and some, if there's not capacity, then the important ones might not come up first. So with VM failover prioritizations, we can set a priority for the VM. So all your high priority VMs come up first, then your medium, and if there's no capacity, then the low priority VMs will just stay turned off. If there's capacity, they'll get powered on as well. So that works well for us. Anti-affinity VM rules. How do I keep VMs apart on a cluster? And actually affinity rules as well, so how do I keep VMs together? Actually, we could do anti-affinity. We could keep VMs apart, but it was this hideous registry entry you had to do, and it was kind of a pain. Much easier to do now. Cluster-aware task scheduling, so a cluster-wide task scheduling, so you can schedule a task to run across the entire cluster. That's quite clever. Live migration queuing is built into the box. So I talked about how there's no software limits on live migration. There are, but you can change it to whatever you like. So there are no limits. But like I said, work out what's appropriate for you. If it's 2, if it's 4, if it's 200, I don't know. But say it's 4 and you want to live migrate 8 machines at once. What you would have had to do in the past is go these 4 migrate, wait, these 4, and so now with the queuing, select all 8, migrate. It will migrate 4 and then migrate the other 4. So it's actually built in, aware of that, and that's in the inbox tools. SMB support we talked about. Hyper-V app monitoring is quite clever. What this allows us to do is run a workload inside a Hyper-V VM and use the state of that VM to trigger cluster events. So that might be, you might be monitoring, say, a Windows service inside the VM itself. So the cluster itself is keeping an eye on the Windows service. If that service stops, that might trigger a failover event. Or you might be looking for a specific event log in that guest. If that event happens, then it fails. That'll trigger a cluster failover. So it's actually, so we're actually looking right up from the cluster itself, right up into the guest, and using that to make sensible decisions. And guest clustering via Fibre Channel, which we talked about. So, with guest clustering. And I think Ben will probably go into this a bit more in the storage session, but we can have up to 4 virtual HBAs in each VM. Each VM has its own, each HBA has its own worldwide name associated with it. So, so they are unique. So you can build your own zones with them. And the host won't see that storage. Just the guest will see that storage. And we use NPIV to do this. So your adapters have to support NPIV, and they have to have a driver that supports NPIV as well. And we work with live migration as well. And the live migration stuff is kind of sneaky because it's kind of hard to do, because there's always that, how do the machine's moving from node A to node B, how do I transfer the zoning over? And actually we end up with 2 worldwide names, or 2 sets of worldwide names per guest, and we use the second set on the failover node. So we actually we kind of swap worldwide names that we're using on the fly as part of a live migration. I think Ben will go into that a bit. So we have done a lot of work around redundancy. And in fact, the bottom bit, hardware fault, so the Windows hardware error architecture, there's some quite clever stuff there. If it detects an error in RAM, it can actually get to the point where it can shut down, where it can stop an individual VM without having to shut down the entire cluster or the entire host, or whatever. It might go, that VM is impacted, shut it down. But there's we've done a lot of work across the stack around this. We have time. Whew, not much left. Automation, PowerShell. I won't say much more than that. There's a crap load of it, and Hyper-V is no different. You can configure this thing up the wazoo. There is PowerShell for Africa, and it's fantastic. It's one of my favourite things inside Hyper-V, actually, is the PowerShell stuff. I'll quickly show you that. I think I'm here. I've got it all pre-staged because it's too long to type in, and I've got a poor memory. So, so create a new VM, TechEd demo. Probably turn up somewhere down here. Yeah, TechEd demo. But I'll probably need to connect it to the network, connect to a virtual network. Cool, done. Change number of virtual processors to 4. Done. Turn on dynamic memory and set a maximum on it, 4 gig. Yep, that sounds good. And I can remove it, but I'll go start VM name, TechEd demo, and away it goes. So PowerShell, you can configure the whole thing from the command line if you want to. You never have to touch the UI if you really don't want to. In fact, these boxes, I'm just going to do this again. These boxes I actually configured just about the whole things with PowerShell. There's an example of some of the stuff that I use to configure. Even from the start, even configuring the network teams with PowerShell, setting the IP addresses, doing all that stuff, renaming it, joining the main, adding Hyper-V, creating virtual switches, setting it up to allow replication, setting it up to allow live migration as well. So so we can do, I didn't actually have to touch any of the UI at all. I just ran a whole bunch of PowerShell commands. It's fantastic. If you don't know PowerShell, learn it. I know we say that every year, and you guys just don't listen. We're going to force you, I'm sure. So networking, a couple of sessions coming up. I'm running a session tomorrow, Ver 305, Hyper-V networking. We'll look into the virtual switch. We'll look into virtual network virtualization. But Daniel is also running the network session as well. So a few things. What customers have talked to us about: network multi-tenancy. They've talked about IP address management. I think Daniel, you're going to talk about network IP address management. Yep. VM bandwidth control, network fabric. How do I meter VMs? Those kinds of things. A bunch of stuff. So the virtual switch inside Windows Server 2008 R2 was, is kind of limited in what it can do, and customers told us, a bunch of things about it. Some of them weren't very nice. And what we've done is the Windows Server 2012 virtual switch inside Hyper-V adds a whole bunch of stuff. So port ACLs, PVLANs, network virtualization, bandwidth control, things called DHCP guard, router guard, some performance stuff, and diagnostics as well. So we add a lot of stuff. Some of the stuff we do, we're talking a lot to hosters, we're talking a lot about cloud, we're talking a lot about, and I know that I try really hard not to say that, but I've said it once. But we've talked a lot about cloud. But one of the things our customers are saying, well, I want to move to the cloud, but it's actually really hard. I've got all these things which are kind of IP dependent. And it's kind of and you'll know it, right? You've got things which everything's fine except for the IP address because it's kind of this one task uses that IP address, and to change it will take 10 years of change controls or whatever. The IP address is kind of this dependency, so we want to be able to move VMs to the cloud and keep the IP addresses. But a hoster goes, well, you want to come on with your IP address range, you want to come with your IP address range, they're the same. That kind of sucks. I've got to use VLANs, and I've got these massive VLAN configuration. Every time I change a switch, something breaks. So this is kind of some of the stuff we're talking to hosters about and customers around network virtualization. So we can do PVLANs inside Hyper-V to, customer 1 can't talk to customer 2, but they can all talk out the same internet connection or whatever it happens to be, those kinds of things. But also network virtualization. So, hey, instead of, like we did with server virtualization, we take, a bunch of physical machines and run them on a virtual environment. They all think they're running on their same physical server. It's what we do with network virtualization. And we'll talk about this tomorrow in Ver 305 about how we achieve this and what it looks like. But, running 2 customer networks on the same physical network, completely isolated from one another with no VLANs, and allowing us to run conflicting IP ranges with no hassle at all, and and also for a customer to be able to bring their own IP address to your environment and bridge their network between your environment and their environment, and that's what network virtualization is all about. We'll talk about that tomorrow. The other thing, one of the things that customers really told us was we want the option to be able to do different stuff in the virtual switch. We don't want to be limited to just what you provide. There's a bunch of partners out there building stuff. And so what we've done, again, we'll look at this a bit more in V305, is we've looked at the Hyper-V extensible. We've added extensibility to the virtual switch. We've added a whole bunch of different extensions. So we've added capture extensions to allow you to inspect traffic and do stuff. We've added WFP extensions that allow you to basically modify traffic as it goes through. We've added filtering extensions, which are basically the same as the WFP ones, but they're just written differently. I've also written forwarding extensions. So if you want to replace the forwarding logic of the Hyper-V switch altogether, you can do that with Windows Server 2012. So things like the Cisco Nexus 1000V, you can basically replace your forwarding logic inside Hyper-V with the Cisco Nexus 1000V. So, and it's just an extension inside the Hyper-V virtual switch. Same with NEC. NEC are doing an OpenFlow virtual switch as well. So, so there are options to do different things here. So I'll quickly take a look at that. So what we've got inside this host here is I've actually got the Hyper-V virtual switch, and we've got an extensions option here, and I've got the S-Flow traffic monitoring capture extension. This is basically just doing a sample periodically of the traffic going through the virtual switch and firing that off to an S-Flow collector. That's all that extension's doing. It's configured in the registry. It's kind of a next install kind of thing, and then you just come in and enable it. And here you don't have to take the systems down to do any, to turn the extension on. You just turn it on and away it goes. And basically, with that extension, not very exciting demo, right? Good one, Stu. But with that extension, what we're doing is we're getting in fact, I've got it on 3 different hosts here. With that extension, we're actually firing a whole bunch of information back to the S-Flow collector, and so we're seeing all this information coming back around. We've got a whole bunch of different things we can do around, all our different, all our different kinds of graphs we can do. And these are all. This is all just the data that's coming back from that S-Flow collector, and we can build these nice, pretty pictures and do stuff with them that network people like. And I've got no idea. And we're also actually collecting things like there's host statistics, right? So we're actually seeing percentage CPU utilization and those kinds of things. So we're actually seeing what's happening down at the host as well. So. We can see memory, those kinds of things. So we're actually getting a bit of information about the host back from this extension. So this extension, real simple one, but really powerful. And in fact, I don't know if I'm right, but it seems to be free. So you can just download it you go to the Inmon website, download it, and away you go. And so is this S-Flow trend tool as well. So if you want to look deeper inside the Hyper-V virtual switch with the Inmon stuff, it seems to be free. So, how are we going for time? 5 minutes? I told you I wasn't going to get through all this. So, other stuff. So the virtual switch, extensible, all those things. Port ACLs, PVLAN support, NIC teaming, network quality of service. We'll look at this tomorrow in V305. So the ability to set bandwidth limits and caps and floors on a per VM basis. So you want to restrict network traffic. We want to do that stuff. We can do that real easy. Network metering. So to do chargeback, and I think Nathan talked about that in his session. We want to meter the VM. Networking is one of the things we meter, so you can do chargeback based on network utilization. Dynamic VMQ and SRIOV support are both scalability features that allow us to take advantage of hardware-specific features in the network card. And what we do with that is, that allows us to offload operations down to the physical network card, as opposed to, the hypervisor or the host OS having to process it. So if you've got, hardware support for these things, we can offload, and obviously that makes our environment more efficient. And there's a few things here. A couple of other bits. DHCP guard. I don't know how many of you have worked with developers before, and hopefully there's no developers here. But I work with a few, and my favourite thing that developers do is you go, here's this VM, and they go, yeah, cool, we'll stick this DHCP thing on there because that sounds fun. Then we'll create the scope, and then, oh, look, that's really cool. And all of a sudden, you're getting DHCP addresses from some random VM somewhere, and your VoIP phone stopped working, or whatever else, and everyone goes, I can't get to the network. DHCP guard's a really cool feature, and I think it should be called developer guard, and you just go DHCP guard, and it stops things acting as a DHCP server inside that VM, so you can restrict that. Great for hosters, those kinds of things. And router guard is kind of a similar feature to stop VMs advertising themselves as routers. Any traffic that tries to come out that says, hey, I'm a router, just gets dropped. And port monitoring was a big ask from customers. How do I know? How do I look at traffic that's going through a particular, going from a VM, going for a particular VM? Port monitoring allows us to do that as well. QoS we talked about, and VM mobility. In fact, I'm going to have to really go race, aren't I? I'm miles behind. So VM mobility. Got 15. Oh, 15. Oh, okay. I got 15. All right. Well, I'm still going to have to race. Not as much as I thought, though. VM mobility, don't do stuff that makes me have to turn off live migration. Don't make me lock a machine to a host or do silly stuff. But I want to be able to move machines, and I want to be able to move machines anywhere. So I want to move them, inside a cluster. But you know what? I actually don't really necessarily want to have a cluster to be able to move VMs. I want to be able to move machines between standalone hosts. Let us do that. Wouldn't that be cool? So we've done some stuff around that. But when we do migrate, don't leave stuff behind. So, I might have network policy applied to that port. Don't leave that behind. Or I might have metering data. Don't leave that behind either. Bring the stuff that, that's relevant to that VM. Bring it along for the ride with live migration. Don't just leave it sitting at the host. Make it part of the VM. So we've done a few things. Obviously, we've done all improvements to live migration. So, we do our live migration that we talked about, no limits. Except for hardware. Live storage migration, same thing. We can live migrate on SMB file shares as well, not a problem there. I won't go into this too much. Live storage migration actually is one of the operations that we can use to leverage that ODX stuff. So we can offload the storage bit of it down to our SAN. Nice little feature. It means the live storage migration is faster, and the OS has to do less. But we've also introduced this thing called shared nothing live migration. And shared nothing live migration is that concept, hey, I want to move a machine between two hosts that aren't clustered, just standalone hosts. I want to be able to move them, but I want to do it live. And shared nothing live migration allows us to do that. And there's been I saw a bunch of argument on Twitter, which is probably goes without saying, it's one of those tautologies, isn't it? I saw some argument on Twitter, about what a silly name shared nothing live migration is because you've got a network cable. It's like, yes, but you have shared nothing between the two hosts. But shared nothing lets us migrate across a network connection without incurring downtime for our VM. So our VM will move and stay up during that entire thing. I don't have time to show you that, otherwise I would show you that. But it's basically just a move VM from host to host, and away it goes. And so it will do it live. And it's kind of clever. DR. We're getting to the end, I promise. The last, Ben is doing yet another session on DR for Hyper-V with Hyper-V Replica. So he's going to deep dive into Hyper-V Replica and how it works and what it does and those kinds of things. So DR, a lot of people don't like the cost of DR. It is expensive, complexity. It can be complex. It can be quite inflexible. Replicating initially is kind of hard. Some things have got distance requirements around them. Like it can't be too far because the networks won't. There's too much latency or whatever. What we've done with Hyper-V is just ignore that one there, that's not relevant. What we've done with Hyper-V Replica is again, a feature that's in the box in Hyper-V that allows us to replicate virtual machines from one host to another, be they in the same data center, be they in different data centers. It is software-based replication, so it's not hardware-based, and allows us to do things like a planned failover, an unplanned failover. It allows us to test our failover. It allows us to pre-configure IP addresses on both ends, so I can fail over to one side, pick up a new IP address, fail back again, pick up another IP address. So we can actually do that stuff. I say Ben's going to talk more deeply about this, but it is, it is built into the box. Again, it's an option you turn on, and then a replication is turned on per VM as well. And so so it doesn't matter if you're using, EMC storage at one end and NetApp storage at the other end. Doesn't matter. We don't care about that because it's all done in software. So I'll give you a quick look at that as well. So probably the other side. No, that was the one I was on. Good. 4. So I've got this machine here, SF Replica, and I've got replication turned on here. So I can view replication health, and it'll show me that it's replicating well, everything's going fine. And in fact, I think if I was prepared, which I may well have been, I set up a task to just show that it wasn't complete smoke and mirrors. And basically, I've got this content file which has got, about right, 1228. That's the time at the wrong time, but it's roughly enough. 1228, so it's writing a log to that file every minute or so, and we're replicating that server over to another host. So what I'm going to do is I'm going to shut this down and do a planned failover. So planned failover, you're thinking about it, so you're going to shut down clean, right? Unplanned failover, obviously things turn off by themselves, and you have to do something different. But a planned failover, I'm going to turn this off, and I'm doing this all through the UI. But bear in mind that this is all fully scriptable through PowerShell, those kinds of things. So you don't actually have to use the UI to do stuff. And I'll just quickly show you the network settings here. So I've got a network adapter. So this is my failover. So my IP address when it fails onto this host is 210, and when it fails over, it's going to pick up a new IP address. So I will go replication, planned failover. And I will go failover, and it's going to fail over to the replica host. So it's basically does some checks, and then what it's going to do is reverse replication, so that when I come time to fail back, it's actually going to be it will already be replicating back to the other host for me. So I don't actually have to enable reverse replication or anything, or enable for failback. It's actually already built in. So there we go. We're now over to BPC vhost 05. So we'll go over there and take a look. And there's my replica machine running, or just started up. And again, you'll see on this side, my IP address is actually 10.0.0.21. So that's the IP address it's going to use when it's running over on this replica side. And once the integration components come up, you'll see down the bottom there the IP address it's picked up is 10.0.0.21. So that failover, that was my planned failover scenario. Unplanned failover is kind of the same thing, except the machines are all turned, machines have died anyway. So, but that's how easy it is to do Hyper-V Replica. Super easy, software-based, and it just handled the process for me. So, like I say, all fully scriptable through PowerShell. And so Ben's going to talk in a lot more detail about that. Yes, and I know we don't have time for questions, but if you find me during the breaks or whatever out there, then ask me things. Oh, I was going to show you nothing, but I won't bother there. So Hyper-V Replica, it's all software-based. If you want to use hardware-based stuff, then do that. Hyper-V Replica is a kind of a 5-minute basis, so it's not a configurable interval, but there's a 5-minute basis for those replications. If you want to do faster replication, you want near real-time replication, then go and talk to your storage vendor and let them help you with that, and you can give them your checkbook. So easy setup, all done. And like, literally, there is no special configuration apart from enable this server to receive replication and enable that server to send replication. That's kind of it, really. There isn't anything hard to do at all here. Look, we are going to get to talk about Linux. How exciting! So with Linux, what we did was. All the drivers for Linux, we actually released the open source community. And so it's part of the Linux kernel now. So I didn't spell Ubuntu wrong on purpose, I promise you. We released the Linux drivers under the GPL into the Linux kernel. And so in March 2012, that was when that happened. We became one of the top 20 contributors to the Linux kernel because of that. And so what's happened is, if you pick up a instance of Linux running a modern kernel, I can't remember what version it is, 2.6.32 or something, I think, or 3.6 or something, I don't know. It's, they actually include the Hyper-V drivers in there. So you can pick up any Linux distro running that kernel, and they will have the drivers available to use the high-performance storage, so the synthetic SCSI, synthetic networking, the mouse drivers, those kinds of things, all as part of the kernel. So you can run Linux and take advantage of all the high-performance stuff without having to install extra drivers or whatever. We still ship the drivers out of band as well, but if you're running a modern kernel, you can do that. We support running on Hyper-V. We officially support running SUSE Enterprise Linux, Red Hat Linux, CentOS, and FreeBSD. I know FreeBSD isn't Linux, and so don't shoot me if you're a Linux person. But it's Unixy. So we support those for. If you want to run the others, they're unsupported, but because the drivers are in there, you'll still be able to take advantage of the high performance stuff they've got in there. So Linux, we support all the, we support the high scalability, we support clustering, we support live migration, we support shared nothing live migration, we support replicating with Hyper-V Replica, we'll support running stacks and stacks of memory and stacks of CPUs on them with the latest integration components. So all good to run Linux on Hyper-V. And that's kind of the message, really. We can run them as well as we can run Windows. And so the last little bit, Hyper-V Server 2012. So I don't know how many people know about Hyper-V Server. Anyone know about it? It's kind of it's the free version of Hyper-V. So basically, it's an ISO you download from our website. It's completely free. You stick it in your DVD drive, boot off it, install it, and basically what you've got at the end of it is a server core edition of Windows Server running with the Hyper-V role pre-enabled. You do that, but it is server core only, and it's all command line only. But that's not a big deal these days. But it is the great thing about Hyper-V Server is that it is fully capable. So everything we talked about today, shared nothing live migration storage, live migration, replica, all that kind of stuff. It's all built into Hyper-V Server, so the free edition. So you can actually you can download it and install it. In fact, it's available as of today. It also got released as part of the RTM release of Windows Server 2012. Hyper-V Server came out as well. You can go and download it and play with it. It's basically it's fully capable. We don't limit its capability at all. So people there's our licensing model that goes along with Windows Server, standard and data center. But if you're not running Windows Server workloads, but you still want to do virtualization, there's essentially no point buying Windows Server to do that. You can run Hyper-V Server and run Linux VMs on it, at no cost. It's a great VDI platform, so you want to run a whole bunch of Windows 7, Windows 8 VMs, run it on Hyper-V Server. If you're a hoster, want to run it, do that. So there's the URL, microsoft.com/HVS, Hyper-V Server. Yeah. So if you want to run Hyper-V Server, the free edition, you can get it as of today. And it is, like I say, it is fully capable. We support the big scale, 64 processors, up to 4 terabytes of memory. We can support 64 procs per VM. We support all that stuff. There's no real limits on it, which is pretty cool. The only thing you don't really get with it is the Windows licensing use rights, and that's pretty much the difference, and a UI, actually. And that's it, and you manage it remotely. So look, actually we did manage to race through all that because I raced through a couple of things. There are some of the other related sessions. I think I've referred to most of those during the session, but there are other virtualization sessions. Brendan's running a planning, designing Hyper-V Server or Windows Server Hyper-V infrastructure. session, which I haven't got up there. There's the sessions in the Windows Server track around networking and those kinds of things. There's the management track, some of the stuff in there. One of the things we didn't look at was things like Virtual Machine Manager 2012 SP1 and what's coming in that. Things like the logical switch. We'll have a look kind of at some of the network virtualization stuff tomorrow, but could look at some of that stuff as well. So there's a stack load of stuff coming, and so there are some good sessions to go to cover it. I'll be here for a couple of minutes if anyone wants to have ask some questions or whatever. Remember to fill in your evals. And remember, best tweet, Ver201 is your hashtag for Twitter. If you're not signed up for Twitter, I'll give you till, I don't know, what time is it now? 1 o'clock, I'll give you to 2:30 to tweet. That gives you an hour to sign up to Twitter. Best tweet wins the Samsung Series 9 notebook, embossed with Windows Server 2012 logo, so it's really nice. And there will be other prizes of that ilk in some of the other virtualization track and some of the Windows Server track stuff as well. Any questions? There's one here.
Just a question on regarding the 2008 R2 migration cluster. Now that Server 2012 is coming up, it's got all the wonderful stuff. How easy is it going to be for us as institutions to now go to Server 2008?
So you're running currently 2008 R2? So the question is, what's the migration path, I suppose? Unfortunately, the migration path is kind of a you've got to get those VMs out and then and import them and basically build a new infrastructure side by side. That's unfortunate. Upgrade the host. There is no in-place upgrade for the cluster though. It can't be the same host, but the same cluster. You've got to build a new cluster. Yeah, and sort of slowly migrate. I know it's not a great story, but that's the story that it is. Any other questions? Do you have any new tools for converting VMware VMs? Absolutely. Just today, in fact, we released the Virtual Machine Converter Solution Accelerator or something. It's on the Microsoft.com site. I think it's on the download site. If you search for Virtual Machine Converter, you should find it. But it just got released, I think, yesterday or today. It's pretty new, but it is built to migrate vSphere 5 and 4 VMs to Hyper-V. Cool. Thank you all. Enjoy your lunch.